Alright, let's talk about your nerves. No, not the ones you get before a big test, but the actual wires inside your body that let you feel, move, and even think. Imagine you're sending a message from your brain to your foot. It's like sending a text. But instead of cell towers, you've got nerve cells, neurons, carrying the message. And here's the thing, not all neurons are built the same way. Some are wrapped up in a special layer called myelin, others aren't. Now, to really get why this matters, let's use an everyday analogy. Picture two water slides at a theme park. One is a regular open slide, and the other is a super slick tube slide. If you throw a ball down the open slide, it might slow down, catch on the edges, or even stop if there's friction or water resistance. But throw that same ball down the tube slide, and it just zips right through, super fast, barely any resistance. That's basically what myelin does for your neurons. Myelin is like that smooth, slippery coating on the tube slide. In scientific terms, it's a fatty layer wrapped around parts of the neuron's long wire, called the axon. This layer isn't just for protection. It actually changes how the electrical signal, called an action potential, travels. In non-myelinated neurons, the open slide, the signal has to move step by step, like walking a tightrope. It's slow, because the charge has to constantly open tiny gates along the whole axon, letting ions in and out bit by bit. But in myelinated neurons, the action potential does something super cool. It jumps from one gap in the myelin to the next. Those gaps are called nodes of Ranvier. So instead of tiptoeing the whole way, the signal leapfrog skips, making the journey way faster. This is called saltatory conduction. Saltatory literally comes from the Latin for jumping. So why does myelin make things so speedy? First, it insulates the axon so the electrical signal doesn't leak out. Second, by forcing the signal to hop between nodes, it covers more distance in less time. Myelinated neurons can fire signals up to 100 times faster than non-myelinated ones. That's the difference between waiting ages for your text to send and going viral in seconds. Bottom line, your body uses myelinated neurons for the jobs that need speed, like moving your muscles or sensing pain quickly. Non-myelinated ones are fine for slower messages, so next time you react in a split second, thank your myelin. It's the ultimate high-speed internet for your body. Science is just awesome, isn't it?